We all talk about the weather. So hot today, oh, it's getting cold, looks like it might rain. It's like the universal conversation starter, right? But what if the words we use don't really mean what we think they mean? Let's get into the actual science behind our daily forecast. Just think about it for a second. When you say it feels chilly outside, what does that actually communicate? Is your idea of chilly the same as mine, or someone living in a completely different part of the world? This simple question, believe it or not, gets right to the heart of why we need a better, more scientific way to talk about the weather. So check out this little story. You've got Krishnan in Chennai, and he tells his friend Amir, who lives up in Kashmir, that it's gotten chilly after some rain. Now for Krishnan, chilly might be, say, 20 degrees Celsius. But for Amir, that's a beautiful spring day. What's cold for one person is perfectly warm for another. And this shows us exactly why we need a shared scientific standard to talk about this stuff. And that, of course, brings us to the science of it all. So let's move beyond just our personal feelings and take a look at what weather truly is from a scientific point of view.
Okay, here it is, the core definition. Weather is simply the state of the atmosphere, that huge blanket of gases surrounding our planet at a very specific time and in a very specific place. And really, to get weather, you first have to understand the atmosphere itself.
So the best way to picture the atmosphere is to think of it like a giant layer cake. It's got several different layers. The one we live in, the one right down here closest to the ground, is called the troposphere. And what's wild is that pretty much all the weather we ever experience, rain, wind, clouds, you name it, it all happens right here in this bottom layer.
So, to really understand what's going on in that layer, scientists measure 5 fundamental things. You can think of these as the essential building blocks that, when put together, tell us the complete story of the weather at any given moment. And here they are: temperature, precipitation, atmospheric pressure, wind, and humidity. We're going to break down what each of these means, but before we dive into all the modern tools and tech, I think it's kind of cool to take a quick look back and see how people figured out the weather before any of this stuff existed.
Yeah, long before we had weather satellites and fancy instruments, people were total experts at reading clues in nature to predict what was coming. It's this incredible knowledge that's been passed down for generations, and honestly, some of it is pretty amazing.
For instance, have you ever seen ants doing this, marching in a line carrying their little white eggs? Well, when they start moving their eggs to higher, safer ground, it is a very, very strong sign that some heavy rain is on the way. Or what about the sound of frogs? When you hear that really loud, almost excited croaking, it often means they're getting ready for rain. It makes sense, right? They need those fresh puddles to lay their eggs.
And this one is just brilliant. Pine cones are basically natural hygrometers. That's just a fancy word for a tool that measures moisture in the air. When the air gets humid, their scales close up tight to protect their seeds. But when the air is dry, they open right up to release them. It's nature's own little forecast.
Okay, so as fascinating as those traditional methods are, today we really rely on precise scientific measurement. So let's get back to those 5 key elements and check out the modern tools of meteorology.
First up, temperature. This is the one we're all the most familiar with. It's just a way to measure how hot or cold the air is, and we usually see it recorded in either Celsius or Fahrenheit. And a data table like this gives us a great real-world example. You can see the maximum and minimum temperatures recorded over a week. From this kind of data, meteorologists can figure out stuff like the daily range, that's the difference between the high and the low, and even the average or mean temperature, to track how things are changing over time.
All right, next up is precipitation. This is basically any form of water, whether it's liquid or solid, that falls from the clouds. And we measure it with a super simple but really effective tool called a rain gauge.
Now for one that's a little less obvious, atmospheric pressure. It's, and I mean this literally, the weight of the entire column of air above you pushing down. You know that heavy feeling you sometimes get in the air right before a big storm? That's actually your body sensing a change in air pressure. And we measure that with an instrument called a barometer.
So this number here is super important. Around 1013 millibars is considered normal atmospheric pressure at sea level. Now, if a barometer shows that pressure dropping way down, that's a signal of a low pressure system. And here's why that matters. Low pressure means the air is lighter, so it starts to rise. As that air goes up, it cools down, and the water vapor inside it condenses into clouds, and eventually rain. So a big drop in pressure often means a storm is on its way. Element number 4 is wind, and it is directly connected to what we just talked about. Wind is just air moving, flowing from areas of high pressure to areas of low pressure. Simple as that. To really describe the wind, we need two things: which direction it's coming from, which we measure with a wind vane, and how fast it's going, which we measure with an anemometer. And finally, we have humidity. This is just the amount of water vapor hanging out in the air. This chart does a great job of showing how a coastal city like Kochi has way higher humidity than an inland city like Delhi. This is the reason you feel so sticky in a place like Kochi. The air is so full of moisture that your sweat can't evaporate easily to cool you down. Okay, so we've got these 5 separate measurements, but here's the thing: they don't exist on their own. They are all connected. Temperature causes evaporation, which creates humidity. Those changes in pressure create wind, which moves all that humid air around. So the big question is, how do all these numbers become the weather forecast we see on our phones every morning?
Well, it all comes together at a place like this, an automated weather station. Think of it as the central hub that combines all the instruments we've been talking about: the thermometer, barometer, rain gauge, all of it. It gathers data constantly, 24/7, feeding us the real-time information that's absolutely vital for everything from farming and flying airplanes to, just planning our weekend.
And I just love this connection. The official motto of the India Meteorological Department comes from an ancient text, and it translates to, "From the sun arises rain." It's such a powerful reminder that even with all our incredible modern science, these 5 elements are all driven by one ultimate engine: the sun.
So we'll leave you with this final thought. We've become incredibly good at measuring and predicting the weather, sometimes with amazing accuracy. But does understanding it mean we can ever truly control it? It's a question that really speaks to the immense power and the enduring mystery of our planet's atmosphere.